Hey guys. Good to see you. My name's Fig, one of the co-founders of Squid. We're a project that does cross-chain swaps, cross-chain contract calls, and we have an API that lets you swap between about 85 chains in one click, and we have an app that lets you swap between tens of thousands of tokens. I'm going to be talking about a pretty technical thing. It's a mechanism that we're using to further decentralize the way that we do cross-chain swaps, and it's called sealed bid auctions. We released a paper on Valentine's Day, I noticed. That's what I was doing on Valentine's Day. I was here in Korea by myself and releasing a cryptography paper. But we released it then, and it's something that I'm working on with a project called Fairblock. They're a Cosmos chain. I'm from Squid, and we're thinking about implementing this in our cross-chain swaps at the moment, but want to share just how it all works. So the background is that intents are taking over the world. They're a swap mechanism which is extremely efficient. CalSwap and UniswapX are crushing it on the single chain swaps. Essentially, it allows you to directly peer-to-peer swap a token with a market maker. So rather than needing to rely on on-chain math or other kind of security, smart contracts, all these kinds of things, you literally just send a token to the market maker and they send a token back. Extremely simple. And you move a lot of the logic off-chain, but try to keep all the security assumptions on-chain that you need. And then in cross-chain, it's really efficient because you don't have to wait for finality times across chain. It's instant. You have this really amazing ability to batch transactions as well. So when you're say you want to bridge USDC from one chain to another, rather than needing to verify every single message, you can say batch 100 users USDC transfers across chain, and then in one single cross-chain message you can verify all of them at once. So it's become really, really successful, and I think it's going to be a big part of the future of crypto, finance, all of DeFi. With an intent, the way it works is, say I want to swap ETH to BNB, I declare that on the source chain, and then a solver, which is often just a traditional market maker, they'll provide a quote for how much BNB they would give you. Then the user accepts this quote, maybe on the front end, by locking in some ETH on the source chain. And then the solver sees that you've locked your ETH and provides BNB to you directly on the destination chain. And then lastly, we have settlement, which a bunch of different projects have their own mechanisms, but the ETH is essentially unlocked and sent to the market maker. And the way you get pricing for these at the moment is generally quite centralized. The easiest way is an off-chain request for quote. So when you go to a front end and you get a quote, you're literally just sending a request to a centralized backend somewhere, and then it gets requests from all these different market makers to see who gives the best price. And the best quote is chosen by the backend, sent back to the user, and the user can accept it if they want. But generally, they don't know how the price was arrived at, and it's very centralized. Dutch auctions are a way that we've tried to decentralize them, but they're generally quite slow. The way Dutch auction works is you set a price quite high, and then every block or every so often, the price drops. And then once the price is low enough, someone will accept this order. More decentralized, but quite slow, worse user experience. Yeah, so some of the problems with these two methods, the censorability of RFQs is a big thing, and it's permissioned the way that market makers can participate in the protocol. You have to have a deal or at least have some kind of interaction with the off-chain RFQ server. And then Dutch auctions, there's issues with MEV, and also it's not as nice for market makers to have to bid in this way. I think it's much nicer for them to just choose the price they're willing to give and not have to think about the game theory of like the on-chain auctions. Another big issue just practically for developers is if you want to build a variable amount in the intent itself, you want some kind of RFQ will not give you this because you can't call a backend API halfway through a smart contract call. take this example where I want to swap aero on base for, say, Seoul. The first step of that route is usually going to be a swap on aerodromes. Velo on base, I should say. Velo on Verodrome on their AMM. And so you will never find out, you won't know the amount you're going to get out of that first swap until after you've actually executed it on chain. And then the second step, if you're using RFQ, you can't get a quote for RFQ using the output of the first swap until you can't do that sort of mid swap on chain. So you have this issue that it's more difficult to compose other DeFi protocols with these intents if you have to have off-chain services running this way. It extends more to projects like cross-chain yield, ETFs. These, like, if you want to build some kind of automated system just on chain, then it's much more difficult to call external APIs. The fairness and transparency issues we've sort of covered, but actually no, we already covered them. It's a duplicate slide. Expiry times. This is actually a bigger problem than you'd think. Like, when a market maker gives a quote, they might hold that price for about 30 seconds, and if the user submits it, say, 35 seconds after they got the quote, it will fail because, say, the market maker gives a price on ETH, they're not willing to hold that price for very long. They're essentially giving an option to the user to, like, buy ETH at a certain price for up to 30 seconds, and then that flow can be, like, targeted by other market makers to maybe they, like, are getting a quote every second, and if ETH does move against the market maker, like, they snap up this order and then they arbitrage it quickly. It means that you have wider pricing than if you have no expiry time. So ideally, we can remove expiry times as well. So the solution that we've come up with is using sealed bid auctions. What are sealed bid auctions? It's where you create an auction. Say I want to swap ETH to AVAX. I lock up some ETH. The market makers need to provide different quotes for AVAX, and whoever the best one will get the intent. They can fill it. But the trick here is that they encrypt their bids before submitting. So because on blockchains everything is usually public, if their bids were public, then another market maker could copy them, or maybe they would bid a little bit lower because they think they can get away with it and then bid higher only if someone beats them. In this case, everyone just chooses the best price they can, and then we encrypt all of them at once at the end, and the winner is chosen. And you can check out the details in the paper, but there's a lot more. There's actually some research that's been done that these are the optimal way to arrive at a price. In intent, we think the best place to put it is the user will escrow their funds on the source chain, or even if it's single chain, they'll escrow their funds. And then, once that's happened, we run a decentralized sealed bid auction. The solvers participate in that. The winning solver will fill it, and then anyone can settle the transaction later. The way that we do these sealed bid auctions is with threshold identity-based encryption. And the trick here is that you do it a little bit like a threshold signature scheme, where you break up private keys into different shares, and then everyone has a key which only together can they sign things. But with identity-based encryption, you create a unique private key for each auction. So it means we can reuse the same validator set over and over and over. We can run as many auctions as we like, and every new auction has a new ID, and then we combine that ID with all the validators, and then if enough of them agree, we can decrypt all of the orders together. Just makes it's a very simple, very low, what's the word? Not much compute needed for this. So it's more efficient than using like fully homomorphic encryption or ZKs. But we could extend it with TEs, fully homomorphic encryption. The issue might be that the user's intent is still public. The solver's bids are public after the auction is completed. So you could extend it with that, and we talked about this in the paper. But we think that just making a fair market is really the biggest upside here. And we can get better prices for users, more open participation from different solvers. This is our Twitters. That's me, Squid, and Fairblock on the right. And yeah, thanks for having me.